Hey, that's my image on Times Square! So it's actually really exciting. Of all the things that we've done in the lab, this has generated the most excitement that anybody. So people are going, it's going to be on Times Square. It's really exciting for us.
Wow, it's fantastic. It's a totally unique experience. A great way to celebrate the imaging competition and winning it. And so yeah, really pleased with it.
Absolutely incredible. I think it's such a one-in-a-lifetime opportunity to see your research that you've been doing for the last 10 years show itself on Times Square, and the impact it can have in terms of colour and uniqueness, and to see it actually up on the big screens here in New York.
So we use the OMX super resolution microscope, and it's really the ability to resolve things that we couldn't previously do with conventional microscopy that's made this research possible. So we could see the two chromosomes as they zip up together. We could really see them at a resolution that meant we could decide whether they had paired up or not. So it was a tool that was really required for this experiment.
Well, I used the InCell Analyzer 1000 to capture the specific image of a lung cancer cell under a condition known as hypoxia, in which case within the tumour there's very little oxygen, and as a result tumour cells overcome this hypoxic environment. The chemotherapy that is used to treat these cells become ineffective. Using the InCell Analyzer 1000, this has given us a visual impact of what a cancer cell under these conditions actually looks like. And I think this has brought a lot of awareness to people who are non-scientists to show how complex these actual cancer cells are.
So our image is showing something called a synapse, or a junction that happens between neurons and the muscle cell. So when the neuron fires, the muscle cell contracts, and we're really interested in how that develops. So we've used a delta vision system now for a very long time, and it's one of the most powerful techniques for looking at normal protein levels, being able to detect minute changes, looking at live cells. So it has a majorly impact on our research. We couldn't do it without the system that we have.
I think it's a great opportunity to show it to the public. They're very aesthetically pleasing and attractive images, so hopefully they'll take that away and be able to apply it to their own sort of learning experience as well.
Well, I think thanks to GE Healthcare and the imaging platforms that are now available, I think this will perhaps, I hope, be an inspiration to other budding scientists who are taking their research forward. Will be able to use these imaging platforms for a lot more detail on the complex mechanisms within cancer and other types of disease states.
Hopefully it'll inspire people to see the beauty in science, so we all see scientists with white lab coats and working in a sterile environment. And science isn't like that. It's dynamic, it's artistic, it's beautiful. I hope it inspires people like that.